Hello everyone, today I'm gonna introduce my new research project, which is a map traveling research doing on Android phone. So here basically we have an Android application, a prototype, which is a 3D map around Columbia University, and currently we are standing at the intersection of Amsterdam Avenue and 116th Street. So in the application we can see a 3D map with models, and we can turn around to look around the 3D maps, and if we look up we can get the panorama pictures, and we can also look around and look into the sky. So basically what we're gonna do is to design a method to travel in this 3D map. We want to go anywhere we want on the streets and look around to see if there is anything interesting and attractive for us. To make interactions more intuitive, we decide to use finger interactions such as dragging. By dragging on the ground, we can go forward and backward. So when we are on an intersection, we can change the dragging direction in order to make a turn, so that we can go into the different direction. So the main drawback of this interaction is, first, it's hard to make a turn, and we have to be really careful to make sure that we are currently on the intersection positions. Another drawback of this interaction is that we have to rotate the camera in order to look around. This makes our traveling much more difficult. Based on previous experiments, I realized that using gyroscope only may restrict the interactions and increase physical movement. So I introduced a new hybrid traveling system, which is also based on dragging or sliding interaction. This interaction detects the user's finger movement on the screen by angles instead of doing rate casting. By dragging vertically, we can go forward and backward. To make the interaction faster, inertia is added to accelerate the interaction. By looking at arrow indicator, we can know which direction we are currently facing to. By a single dragging or inertia on a section, we can only reach the end of that section instead of going further. This makes it easy to make a turn. For example, if we want to make a turn at the next intersection, we just go forward. It automatically stops at the intersection so that we can make a turn. In order to prevent arrow manipulation, the application detects the initial angle of our dragging and keeps in that mode until the finger is released. For example, if I want to make a rotation here, I simply drag my finger on the screen horizontally and enter the rotation mode. And no matter how my finger moves, I keep rotating until I release my finger. But the exception is made on the intersections. Users can switch between translation and rotation within a single drag in order to accelerate the turning interaction on the intersections. For example, if I want to turn left and go forward, I simply do this and this, instead of releasing my finger in the middle. GUI buttons and sliders are also added to accelerate the interaction when users are traveling egocentrically. The control buttons and the sliders appear when available. Users can walk along the street and look aside simultaneously. For example, if I want to travel through this street, I can go forward by pressing the button, and go backward, and I can look around, and I can go left by this slide, and go right. With the multi-touch interaction, users have more freedom to control themselves on the street. They can either rotate the phone or drag the screen horizontally to look around while traveling along the street. To provide users with more information, a rear camera view is applied when user is in the egocentric mode. The rear camera can be dragged into any position in the screen in order not to block the view.